Hello, DJ Necro here. I'm just going to take you through the brief steps required to wire up one of the Mayhew Labs rotary encoder LED ring. This assumes, of course, that you have already soldered the encoder on, which I have already taken you through. Okay, so there's 10 pins, assuming you put pin headers on it. Either way, there's 10 connections. You only really care about 8 of them at the bare minimum, if you want full control over the LEDs and the encoder. If you only need the LEDs, you only need 3 pins. Same with the encoder, only 3 pins required. 2 for the actual encoder and 1 for the button. Okay, so in order from left to right, you have ground, VCC or power, just standard 5 volts, encoder A, encoder B, the switch, and then 3 pins for the multiplexer. You have your serial data, your clock, and your latch. And for these purposes for now, we're just going to ignore these last 2 pins. We will come to them eventually, but for now, we'll just ignore them. Okay, so first things first, what we need. Of course, we need the breadboard. Obviously, we need one of these things. An Arduino helps if you expect to hook it up and have it do anything. Okay, so once we have the breadboard and the encoder ring, we now need little wire jumpers. If you've worked with breadboards before, you hate these things because they get everywhere, they fall on the carpet, you end up stepping on them, and, well, they suck. But they're extremely handy. Okay, so now what you want to do is you want to find a spot for the encoder board on your breadboard. Doesn't matter where, as long as you have room. For this demo, I am going to put it up in the corner here, because I am going to put a MIDI in circuit here, and there will be actually 2 more encoders here. So just leave that off to the side to give yourself some room. A pair of tweezers, very, very, very handy. Can never go wrong with tweezers. And pardon my left-handedness, I will try to do this right-handed, but I might not succeed. So just kind of pay attention, leave it off to the side there so you can reference where the pins are. So we just want the first pin, which will be in hole 21, or column 21. That's going to be ground. Let's use a bigger one. Just a matter of pushing these in. Sometimes tweezers are a little too delicate and they don't work out as well as you would think. Okay, so there's our ground pin. Okay, next one is VCC, or power. Okay, so the reason why I'm putting it on this end is so when I do put the encoder on, you don't see it. Hidden. Yeah, one thing that I like to do early on in a breadboarding project is to jumper these 2 together. That way I apply power anywhere along it and everything gets powered. You don't have to think about it. I just kind of connect both together, positive to positive, negative to negative. Put it the other way around and you may find out how electronics work. Most people don't realize this, but all electronics work on magical blue smoke. And if the smoke gets released, electronics don't work anymore. Okay, so now I have my power rails connected. Okay, so I've already done this before, and the way it worked out best, since I only have the 3 boards, is I'm going to leave this area here free so that I can connect it to the Arduino itself. So because there is a break along the center here, I just need to jumper over that for the different pins that I need access to. So I need one for the SDI. I need one for the clock. SDI is serial data input. And I need one for the latch. Okay, I am going to preemptively add one to the OE, or output enable, because while we don't really care about it, it does need to be wired up. However, it just needs to be tied to ground. Okay, now on to the rest of it, and that's the connection to the Arduino itself. Okay, so I did bring down that OE line, and I know I said that we don't care about it, but we kind of do. But then again, depending on what you're going to use this for, you probably don't. It's used to turn on and off the display itself. If you just want the display always on, but being able to turn on and off the LEDs individually, you would just tie that low, or in other words, tie that to ground, which is what I'm going to do right here. Okay, so you have the output enable line tied to ground. Hopefully you can see that. Okay, so the next step is to get in the trusty Atmega 2009 and some jumpers. These things are a pain because you always lose them and you never seem to have enough of the right size, but they come in handy. Okay, so what I'm going to do based on the instructions, again, always RTFM. We might be men, but that doesn't mean manuals aren't to be afraid of. You know, they're just words on paper. Okay, so according to the manual, and again, the pin assignments here are technically up to you. The library and the examples are already coded to use these specific pins on the Arduino, but it's your program. Do whatever the hell you want with it. Okay, so SDI, serial data, which is the first connection here, goes to pin 2 on the Arduino. Next one over is the serial clock, and that goes to pin 3 on the Arduino. Next one over is the latch, and that gets hooked up to pin 4 on the Arduino. Okay. Now one more very, very important part is not only do electronics require blue smoke, they do require power. So don't ever forget to hook that up. We're just going to hook up the 5 volts from the Arduino and then the ground to our ground rail, like so. And believe it or not, we're done. From here on out, all you got to do is plug it in. And assuming I still have this programmed, power up. Three pins on the Arduino. You're controlling 16 LEDs. And in upcoming tutorials, we'll be adding 2 more for another total of an additional 32 LEDs using only 3 pins. Okay, that's it for this tutorial, getting the LEDs up and running. Next step is going to be daisy chaining these together. In theory, you can have upwards of 255 LED boards chained together. However, I would not recommend it. There's just too much processing time required to drive that many LEDs. However, you can definitely get a couple of dozen, I'm sure, without a problem.